Okay, to do feature-based cost estimation with Nitro-CELL and CREO, we have this very simple model set up. It is a sheet metal component. It does have a flat pattern, and it is set up as a family table instance with a -F option here. To get this to work, what we're going to do is we're going to use this Excel document that's been upgraded with Nitro-CELL to include the functions that we want it to run to actually perform these operations. So what it's going to do is it's going to erase memory and then open up that family table instance that contains our flat pattern. Since we're dealing with a flat pattern, we're going to get a couple pieces of information of it. Number one is what is it made of, which is contained in a parameter. And then we're going to write that to a new sheet called model properties. The next thing it's going to do is get the bounding box of that model and write it to the model properties also. So what it's going to do is it's going to fill out this row of information right here. So once we have that, we actually have some Excel formulas already kind of baked in to compute the area and also to do a lookup of what is the material of the raw material of the item, and then kind of scan for what is the cost of that item and then compute the raw material cost based on the area that we were computing here also. You're probably wondering, well, where's that coming from? Well, actually, we have a Excel worksheet set up here that contains some lookup ranges, named ranges for materials, material costs, and also we have an operation cost for laser operations already predefined also. You can set these up very easily just using named ranges. As you can see here, this range is laser cost. If I highlight this range, you'll see it's where my raw materials are coming from. The execution worksheet is then going to move on and extract the profile data of the flat pattern as well as the total length of travel required to cut that shape out of the raw material. We have this function called getAppend flat sum, and all it does is it writes one row of information about the part, which will include its model name, the number of profiles it has, which we're not really going to use here, and the total length of travel that would be required to cut that profile out of the raw material. As an additional step, we're going to be adding a formula dynamically to compute the raw material cost based on the total length, or excuse me, the processing cost based on the total length of travel required to cut that shape out. So what that looks like here is we actually can write a formula dynamically that refers to that laser cut or that laser cost to the final value that's going to be rewritten. Once we have these two steps done, then we're just going to summarize this data into our cost estimate sheet by writing the values for the raw material and feature costs here. And then we have a formula already set up to kind of summarize that data. So when we press the Do It button, it's going to connect to CREO, load that model up, write the data out, and then switch over to the last sheet so we can see that the estimated cost of this part is $5.19. If we take a look at what it wrote out, you can see that we've extracted our raw material properties, the bounding box for the information, computed the area, and did our lookup for what the raw material cost would be. For the model features, it's indicating that there's 11 profiles in this part, and the total length of the profiles inside and outside is this value here. And then, of course, our lasering cost would be computed from that as $1.70, I guess. So our total costs are being reported here, and this is just one example of many different capabilities you can do for feature-based cost estimation.